In this video tutorial, I will show how to generate a very simple bending moment shear force diagram for a problem that is done with beam elements, and the software that we're going to be using is obviously the 3DEXPERIENCE's FEA solver, which happens to be the Abacus program. The simple problem that I'll be doing is a cantilever beam like that, which is loaded uniformly. And obviously, whatever we do, we're going to have to get the shear force diagram, which looks triangular like that, and a bending moment diagram, which is parabolic, as shown below. Now, often people wonder whether they can get a fancy shear force bending moment diagram like this. The answer is no. This was done in SolidWorks, or about something like that, and the answer is no. That's done in the Answers program. So how does it look when you do this thing in 3DEXPERIENCE/Abacus? It looks a graph like that. It contains the same information, but it is drawn as a two-dimensional plot that you can see here. Now, one thing that you should be aware of, that if you want to generate these graphs, you have to ask for additional data. You have to ask for this thing, N force, okay? And without that, you won't be able to generate these two graphs, okay? And once everything is done, you're going to have to create a path and basically use the XY plot from a path to generate such graphs, okay? One other piece of information that I give you, and this is, although it's not maybe the right place to bring it up, is that in the 3DEXPERIENCE's implementation of Abacus, there is no, there's only uniform load on a beam, okay? In the Abacus program, it is possible to go and create an analytical field which describes that variation of the load, which can be triangular, etc. But this is not available in 3DEXPERIENCE as of this date. Maybe it will be implemented in the future. Okay, so this is the slide that I always show to indicate how you display stuff when you do beam element. Let's go ahead and do that. Now, I have many choices in making this, but this is a two-dimensional problem. So I'm going to draw this line in a sketch and proceed. In tutorial 7, I talked about should I do it in sketch or should I not do it in sketch? Should I join? Should I not join? Etc. So just leave that out. Actually, I'm going to do that in sketch and proceed. Okay, so let's go out here. We start with, since I will be doing it in sketch, I will need to join it. If I decide to minimize my work. So on that vertical plane, I will sketch a line, and that line is going to be my beam right there. Let me make this thing horizontal. Okay, let me dimension it to be 120 inches. All right, exit. There we are. And let's create a material. So let's create a material. I'll call it BM/SF. This is September 14, 2024. I'm going to create that. Where is it? Right there. I'm going to apply that to this. And I have to input the values. Okay, so it is a structural, Abacus multiphysics, mechanical, elasticity, elastic, and it's 29,000 KSI. 29,000 KSI. Oops, what happened? Yeah, and Poisson ratio, I don't need it, but I'll put down 0.3. Very good. So that's done. So now let me not forget to join this thing. The join operation, because I'm in, let's go back to shape design right there. Because I'm in generative shape design, then I go to transform and there's the join. This minimizes the amount of work that I have to do later on if I want to use Sketch. Okay. And I decide to go that route. Yep. Okay. Now we're going to mesh it. So let's go ahead to the structural model creation, MTFEM, and get the mesh tab, beam measure on that, 12 inches long. So there'll be 10 elements along the length, mesh. And now with the cross section is circular. So we go to properties. Where is it? Properties, beam profile, circular, radius is 2 inches. Okay. And then we create the section property. Beam section, we select that line. We can do that, or actually the sketch. And the profile is beam profile 1. Very good. Let me do a quick save here. Okay, so we're going to go to the structural scenario creation. Basically, we go to the solver, select the final model that was created, the mesh that was created. Okay, and on the procedure, we use static perturbation because this is a linear problem, and all I want to do is to show you how to generate the bending moment shear force diagram. There's no reason to do, anything else. You can do static step, and then if you want, uncheck the nonlinear geometric effects, etc. But this is fine. Now, as far as the boundary condition goes, clamp that end. Okay, and apply a uniform beam load. So under loads, do a beam loading right here, beam load. And this is what I was talking about in the slide, that you only have the uniform one. You can see that there is no other option. It's a uniform, there's no other option. And there's no f of x here, so that you can go actually and create something and then upload it. But anyway, so that's going to be minus 10 pound per inch. Oh, I forgot to select the support. Where is it? There's the load. I forgot to select the support, which is right here. Very good. And that's pretty much it. So let's go ahead and run it. So we go to simulate. Let's do a quick model and scenario check. Should be okay. And then I'm going to run. I'm not going to bother simulation check. I'm just going to run. Oh, oh, oh. Don't forget to ask for output, additional output. Before you run, you have to ask for additional output. Before you simulate, additional output. So let's go back here. Click on this. And under force, select for that guy right there. So that's what this thing is. All right. And then we say OK. And now we simulate. It's going to be a quick run, and the tip deflection that we're going to check it out is going to be 0.714. That's an indication that agrees with the theoretical solution. And then we're going to plot the deflection, bending moment shear force. And the deflection too, Let's go back here. When it comes to doing this path plot, there are different ways that can be done. What I will do is to select all the nodes that are on that line and ask for the data to be plotted for it. Okay? There are other ways of doing it too. So let me close that. First of all, look at the deflection, displacement, 0.714 as I expected. Now, what I need to do is to go here and create a path and then plot something. So let me go ahead and create a path for myself. If you're having a hard time selecting, for example, uh, there are different ways of doing it, so this may not be the best way. But let me go to the plot and then show me the node labels, apply, so that I can see where they are. Okay. And what I'm going to do is I'm going to say under the setup, here's a path. And the path, I'm going to use nodes to do that. As I said, there are many different ways of doing it. I'll use node, and I select these nodes one by one to this one, that one, that one. If you want, you can type it here too. There are a lot easier way of doing this thing. 11, and then, so what we want is the path to have these nodes. We say, okay. And then you go to the, see, this was setup where you create the path, and then you go to plots and scroll to the right. And here's XY plot from the path. Choose the right path. Path one, there's only one. Okay. And I want the displacement, for example, at the nodes, and then say apply. There we are. So there is your 0.714. Okay. Now, to plot the bending moment shear force diagram, you change the template so that you can see what you're doing easier, reaction forces, and you find that, where is this guy here? Oh, and force right there. So this will give you shear force, this will give you bending moment. So you select that. Okay, so this is going to be, once you selected the magnitude, you say apply, and you get this horrible looking graph. And the reason is that you have to change this thing to nodes, not element nodes, because there is no averaging is done here. So close that and change this thing to nodes and then apply. And there it is. And notice that it starts at 1200, it goes to 0. The reason that it's broken like that, it doesn't go sharply to that location, is because the mesh is very coarse. Okay. So I'm not going to bother making a finer mesh, but it basically the straight line. You can try it. Use a different size element, smaller, you see that it's going to go nicely down. Now, to get the bending moment, you go here and you select the other guy. And then again, magnitude, and once again at nodes, so that averaging is done. And then you're going to get, you're going to say apply, magnitude, apply, and you're going to get this. You might say, wait a minute, that looks like that, except that it is down, because this is the magnitude, this is actually this is the magnitude, that's why the negative sign is gone. Now, the only thing is that you might say, wait a minute, but this is not 7200. That's because look at the unit. The unit is pound force feet. So let me go change my units here. Let me close that and say okay. Let me go on to units. And for moment, instead of pound foot, use pound inches, and then say okay. And now I'm going to do the same thing. Plot from the path. Change the template here. So it's going to be the moment and magnitude and at nodes, and then apply. And there's your 7200. Exactly 7200. 72,000, not 7200. But there we are. Okay. So what I'm going to do is repeat repeat this process in tutorial 9 and your I'm going to call it second try, and it's going to be a more complicated basically setup here. All right, it's a very simple problem. Good luck.